welcome to Ladyada.
Hey everybody, and welcome to my desk. I'm like disappearing. I'm so goth. Welcome to my desk where I do electronics all day and all night. And I got some electronics in this weekend, and I'm also trying to kind of get through a bunch of backlog things, stuff that's been waiting the last few months to get done, get fixed. So, spending a couple hours really analyzing, like, stuff that is working, why isn't it working, and then try to get it working so I can get into the shop. All right, so let's go to the overhead and I'll show off the first thing that I worked on this weekend. So these, I had this like weird mystery thing where we did a revision for these eInk FeatherWings. And, as you have watched, I've been doing a lot of revisions. Like a lot of TFTs got revised, a lot of eInks got revised. So the way you can tell is, for easily is I changed the silk screen to be like a rastered silk screen instead of like a vectored. So this one is the new one. You can tell because it's a nice silk screen. And I moved around a couple parts. There was like one resistor that like for some weird reason, like I put like right next to the FPC and made it hard to open the FPC if you wanted to replace the e-ink. So I moved that and, I had to do a couple of part replacements because like stuff was unavailable out of stock. And we had this weird issue where this is the old one, looks beautiful, and the new one has like this kind of weird speckly appearance after it's unplugged. So I'll show you, like, this is the tester for this product. When I run the test, just give it a second because it has to wipe the display. Okay, so it looks like beautiful. This lovely crispy ink display. And then when you unplug it, like 6 seconds later, it does this like whee thing and it starts like getting speckly. And this does happen, but it's not supposed to happen that quickly. It's supposed to like take like a day for it to get like dim. Like this one in contrast, when you compare them, and this one looks much, much better. And I was like, oh, like, is it like the display? It's not the display. Was it like, I looked at all the components, none of the components were really changed. They were just moved around a little bit. And I was like, was it the layout somehow? Or like, what could have happened? And then I actually did eventually figure out what the issue was. And this is when a part swap, sometimes swaps are not swaps. So the diodes used for, there's like a, buck converter and a buck converter to get a high voltage for bias and I think a negative voltage for bias. There's like two DC converters and use this inductor. The inductor did change, and I was like, maybe the inductor. I picked a nicer inductor, but like maybe there was something about it that made the converter not work as well. But actually, the diode, even though the diodes are the same part number, MBR0540, I couldn't get the MCC MBR0540. So I got this other kind of like so-so brand, and from LCSC, and it actually turns out that even though the specs were on paper equivalent, there's something about this, maybe like reverse leakage or something that ding ding that makes the converter like leak current, or like the voltage droops once it's connected faster than it's supposed to. And so when I soldered from the working one these MBR 0540s onto this board, this one's a soldered fixed one, it started working. So, again, it's like during part shortages, like I couldn't get diodes, I couldn't get regulators, like op amps, whatever, transistors. So I tried to find alternatives, and the best choice is always to try to go with the same part number. But in this case, actually, even the same part number was not equivalent. So it does happen once in a while. But thankfully, like I just swapped, like I started swapping every part. I was like, well, I'll like keep swapping. And then when I swapped the diodes, that's when it started working okay. So it's just one of those, like, you have to spend a couple hours and just like, I swapped like one thing, did that help? Swapped another thing. Thankfully, I had a working good version to like compare against. I think it would have been really frustrating if I was trying to do it like, from scratch, like from a base design. So yeah, it turns out the diodes, I thought Schottky diodes were Schottky diodes. Turns out sometimes they're not. And then another component thing here that I did was I got this prototype up and running. So this is, what is the part number again? Oh goodness, it's like the TUSB 30 from TI. It's a USB switch. And so kind of a cool idea. it takes USB in, so this is the host, and then then it has two ports that I just connected cables to, but of course you can hardwire them. And then this S pin determines which one is connected. So some ideas is you have two peripherals in one case and you want to swap them, or one is gadget mode and one isn't, and so like you convert, like there's I think this was like for cameras or like some other devices where you might want to like maybe want to access the internal mass storage through like an SD converter, but then you also want to connect to the microcontroller, so there's just a switch that will let you do it. So it's like designed for high speed too, so it can do USB 2.0. And I was actually, it was working. This board is working just fine. Thankfully, like Rev A, I got it going good. I'm not going to plug this in because it actually takes down my USB hub, which will like take down all of this video stuff, which would be sad to demo. But the reason it was taking it down is because when I plugged this in, I tried to be like, well, like you're switching the USB and maybe we should have plenty of power to like avoid a brownout or whatever. So I put two 100 microfarad caps here. So these are 1206 or 1210. 100 microfarad caps, there's two of them in parallel on the V-bus line. 5 volts. So that actually is more than most hubs and ports want to deal with. They don't like that high inrush current of a low ESR, 200 micro, and then another 10 here. So like almost like 220 microfarads of low ESR capacitance. That's a huge surge of current. And then, my hub doesn't like it. And then it basically resets. So the solution was just swap them out for, a couple of 2 10 microfarads. And then this I changed from a 10 to a 1 microfarad. So now it's from 220 to about 22 microfarads. And that's well within spec. I will say it's something interesting. I remember reading once that the USB spec does not really want more than 10 or 20 microfarads of load when it first plugs in. There's a fuse that protects each port on a USB hub or like a computer. So that, it'll protect you from like, back powering or overcurrent or whatever. But too much surge current will either cause the fuse to flip or cause the power supply to dip because it's not expecting that much rush current. But thankfully, once I did that swap, I just soldered it in. It worked great. So those are two prototypes. This prototype got sent out for manufacture. So they'll get the PCBs manufactured, get those in. And then another one that's just been pending for a very long time is I designed these really adorable TPS 61040 PCBs. And this was also one of those, like, a component swap was making it not work. This is the working good one. I had this working good one, and I use this for like just generating like a small 40 milliamp bias voltage at 12 volts from like 3 to 5 volts. And I did have to do a couple swaps. So like the inductor I couldn't quite get. So I got a slightly different inductor, and this was a solid state, not a wire wound inductor. And then the Schottky diode I did change. This was an MBR 040, and I changed to an MBR 120 because I don't need 40 volts. So I was like, well, let's bring it down to 20. And but otherwise it was the same, and it wasn't generating 12 volts, and it wasn't like enabling. And I was like, I looked everything, and then of course the thing that it turned out to be was this accidentally got pick and placed with what should have been 860K 860 ohm resistors. So the resistor divider was way too low, and so it wasn't boosting. It was like oh, like your voltage is, there's no feedback voltage, so it's like it just shut off. So it's one of the side effects of using ironically, it's because I used 1% resistors, and 1% resistors use a code on them. Let's see if I can zoom in. I don't know if it's gonna be able to see it, but there's like a 3-digit code. Like when you're using larger resistors, sometimes you get like 3 letters that'll be like 103, and that'll tell you it's like a 10K, or 104, it's a 100K. But this was like Y3K Q or something. And like, I should have looked up the code to verify, but I didn't. But you know, I'll just get these, you know, we'll just rework them. We'll just remove this resistor and put it in 860K. And hopefully it'll pop up. It'll work at 12 volts. We'll get this back into the shop, a little bit of rework. But then the next run, I'll fix the, you know, I'll throw away the, you know, bad resistor, put in the good one. And we'll get these fab right. Okay, so good. That's you know, this, and this is like, by the way, I ordered these like a year ago. Like they've been sitting on my desk for like a year. Like, what is wrong with these? Just spent like an hour today and just figured it out. Like it's a good holiday brain cleanser. All right, let's go to the great search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Angel for thanks DigiKey every single week. Ladyada uses the power of engineering to help you. Yes, you find things that you want on digikey.com. Ladyada, what are you looking for this week on digikey.com?
Well, what I thought I would show off was actually just 10 microfarad capacitors. So if you go back to the overhead, you know, just showing off a project where I replaced, well, this, you know, I've got 10 microfarad capacitors here and here. This is a little buck boost converter to 12 volts. So I've got these two big caps here are 10 microfarads. And then over on this board, you know, I've got just, you know, all of these are 10 microfarads, all these chonkers over here. This was a design where I had two 100 microfarads, turns out too big, one big them back to 10. And I realized I haven't done a great search where I talk about getting just jellybean 10 microfarad caps. And we use a lot of 10 microfarad caps. Obviously, you pair them nicely, like a Cabernet with some lasagna. You get your 10 microfarad, your 1 microfarad, and then a 0.1 microfarad. You put them together, you've got a full decade, you know, coverage for high frequency and like bulk capacitance. And we use, you know, sometimes we use electrolytics. And there's times to use electrolytics. So for example, when you need high voltage, a lot of bulk capacitance, this is 47, 25 volt. For the pricing, you just go to electrolytic, but there's still a lot of 10 microfarads. Why 10 microfarad electrolytic ceramics? Ceramic capacitors are inexpensive, easy to pick in place. They're small. They're very low ESR, which means that they'll perform fairly well at reducing high frequency noise. But mostly they're just like really easy to pick in place and small. I mean, like tantalum is like a rare earth metal that a lot of people, you know, it's complicated to make sure that you're getting it like ethically sourced, and also they're much more expensive. So I don't really use tantalum kind of at all. I don't think I've like used it at all. I basically just use electrolytics when I need 47 and above. And for anything below, I use ceramics. And there's only one time I'll say that you should not use ceramics. And there are some power supply chips that need high ESR for stability because they use that the series resistance of the capacitor to stabilize the feedback. I think the MIC 5205 or like there's I don't remember exactly the part number, but I remember seeing once you know, I tried making a power supply with a like an older chip. It was like an old 1117 or something. And I tried building on a PCB with ceramics. It actually wasn't stable. I saw like it was kind of oscillating. When I put on the same capacitance but electrolytic, it stabilized. So, you know, it happens. Okay, so let's go to the computer. Oh, look, there's like some Adafruit stuff in this photo. That's kind of cool. Okay, so your standard 10 microfarad ceramic capacitor is lovely. And there's lots. Don't forget, there's dark mode. But I think it's easier to read the video in light mode, so I'm going to just continue in light mode. So first off, we want only active, 10 microfarad, of course. And then let's just do, you know, in stock and exclude marketplace just to look at what's in stock right now at DigiKey and sold from DigiKey so we get it like instantly. Okay, so now we can actually start, you know, there's still 1,000 options just for the 10 microfarad caps. So the next thing I like to look at is tolerance. And the tolerance is actually related to the, actually, sorry, let's do surface mount. Also, let's avoid through, although there's many through hole ceramic capacitors. Okay. So when you look at the tolerances, much like resistors, capacitors have tolerance, and the tolerance is going to be related to the temperature coefficient, which is also used as, it's like the dielectric. And sometimes you'll see this X5R, X7R, Y5V. So Y5V is going to be like the cheapest one, and that's the one that's plus minus 20%. But like these days, you don't have to go with like I don't really use the Wi-Fi V anymore because you get much better performance from like X5R, X7R. X7R and X5R, I think, is slightly different temperature. Like one is industrial and one's commercial. So I look for like 10, 20% is kind of what I go with. A reasonable price, and also like doesn't, it's not like too wobbly when it comes to the consistency. Next up, your voltage rating. So in general, you want to use the lowest voltage rating for your situation. So if you're, it's a 5-volt power supply, use 6.3 volt. 9-volt power, 8-volt power supply, 10 volt, 12 volt, 16, right? You always go a couple volts up, and then that's your voltage rating. However, I don't want to stock like 5 different voltages for different use cases, because a lot of my stuff is 3 volt or 5 volt. So should I get 6.3? Well, you saw that little boost converter goes up to 12 volts. I don't want to have to pick like, oh, that one cap is a 16 and that one's a... So I pretty much always pick 16 to 25. I feel like that really covers a lot. Honestly, I tend to use 16, but like depending on your use cases, maybe you need that extra boost for 25, go for it. Okay. And that actually cuts it down a lot. So it's like now 350 options. So next is the package case. So, without going into like, a 30-minute discussion, there's a lot of videos about it. The bigger the package, the bigger the package and the coefficient, depending on the coefficient, you're going to have less DC bias loss of your bulk capacitance. What do I mean? So electrolytic capacitors are actually kind of nice in that when you put 16 volts across them, 47 microfarad, you're going to actually get 47 microfarad of capacitance. That's not true of ceramics. The DC voltage across them actually greatly reduces, like easily 50% or more, the capacitance rating. So you buy a 10 microfarad capacitor, you put 6 volts across it or 5 volts across it. Now it's a 4.7, which is fine. You just add, that's why I put lots of them on there. They're only like a penny or two a piece, but it's something to think about, especially if you're like, I wouldn't design these into filters. I think if you're doing filters, you're going to use smaller capacitors, and you'll use C0G, which is a dielectric that doesn't lose the bulk capacitance. But let's just look at the data sheet here. Actually, I don't know if it's in the data sheet. It might be in the spec sheet. Yeah, okay. Voltage derating. So there's temperature derating. As they get hotter, they also lose up to 60%. So watch for that. But the one that is voltage, hold on. It might not be in this. Derating. Okay, this is only temperature derating. Applied voltage. It doesn't have the graph. Okay, hold on. 1 second. If you go to the product page, because I saw this earlier. Characteristics. So this has fairly good temperature characteristics. That's good. But the DC bias characteristics, you can see here. As we go from 0 to like 5, you've lost 50%. And you go higher, you lose even more. And that is a 0805. If you go to, hold on, got mixed up. If you go to like a 1206 or whatever, so let's look at this 1206 capacitor and look at this specifications. Hopefully it's in this document. I probably should have pulled these up. Here you go. Date rating. DC bias. Okay. No, sorry, this is still the X5R. This is not that specific one. One moment. Did I click on the spec? Hold on. Let me find one that has. I may not be able to find it, but basically the larger it is, maybe TDK has characteristic. Okay, so for this one, the 1206 instead of the 0805, you'll notice at the 5 volt, you lose 15%, or if you remember on the 0805, we lost 50%. So the bigger the physically larger the capacitor, in general, check the spec sheet, like, and you see sometimes you have to like look around. It's going to derate, but the derating will vary, and the derating also varies by the dielectric, and the, so it's like Y5, X5R, X7R, C0G, small. Obviously, for like, if you're getting your like 22 picofarad capacitors, those are not going to be derating as much because you're going to get ones that have a high quality dielectric. But when you're talking about the bulk capacitance, it does matter. So you just put like twice as many on. I don't know. They're like a penny or two a piece. So let's go back. I tend to use 0805s, to be honest. So let's look at 0805. And it's about 100 options. And there's a couple of different ones. Again, different voltages. What you're going to be paying for. I mean, you're like, what's the difference? All these Ys are 100. Slightly different heights and sizes. Some are different temperature gradings. And some are just different tape and reel sizes. So like, there's the, this one, like, I think is, I don't know, the G, maybe it's like the reel is bigger. When you get it, there's like a 3000. Yeah, this is like a 2000 tape reel, 3000, 4000, 10,000. That's another thing. If you're getting these caps by the reel, because you're in a pick and place, the 10K piece reels are awesome because you load them once you forget them, but your feeder has to support that size reel. Something which I learned once when I accidentally was like, oh, I'll just buy the 10,000. And we got this like 13-inch reel, and I realized it wouldn't go on the pick and place machine. But if you're just buying these generically, this one is super cool. The CL21A 106 OQNNE 10 microfarad Samsung generic cap. I use these by like the bazillion. We literally sell like 1 million a year through all of our components that go to our products. So that's my pick for the Great Search.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
And that's our show for Sunday. Thank you so
Yeah.
much, everybody. We'll see everybody throughout the week. Just a little bit of reminder, limited number of Ada boxes are going out. We'll be contacting folks soon. We've got gift certificates, and the next couple weeks they'll still be around doing stuff, making open source hardware, shipping, and sharing knowledge, getting it out there. We'll see everybody next week.
Bye, everybody.